It is Friday, June 23rd. This is the CEO of Golden Metal Resources, Oliver Friesen, speaking here. I wanted to do a quick overview of an RNS we put out earlier this week, which highlighted the identification of two further high priority exploration targets on our Pilot Mountain project. I apologize, this video is a few days late. It's certainly been a busy week over here at Golden Metal Resources, but we'll just touch on those two further targets today. For quick reference, once again, this black outline is our Pilot Mountain project, which hosts the largest undeveloped tungsten resource in the US. And what you're looking at here is the red outlines are the current zones of identified mineralization at Pilot Mountain. These are all skarn type zones, and we'll go into detail as to what that means in terms of geology and deposit types. But as you can see here, we have garnet, gunmetal, desert scheelite, which hosts about 85% of the current in-ground resource, and then Good Hope. This yellow outline is the footprint of the 2022-2023 IP survey that we ran. And then these white outlines here are the outline targets of the five new priority exploration areas that we've identified. We previously announced three, but today we're going to go into a bit more detail about this Porphyry South target and then the Good Hope West target. And before we go into that, I'm going to do a quick geology lesson. And this is actually a diagram that we're taught in university geology, but it's important because we've talked about porphyry targets on Pilot Mountain, and I think the market is not fully grasping what a porphyry deposit is, or why is it significant that we've identified porphyry targets. And the reason for that is all the mineralization that has been found to date at Pilot Mountain is considered skarn type mineralization, which effectively just means that that mineralization is hosted within a limestone. Now, limestone units are very reactive host rocks, so when hot fluids with metals hit them, they drop that fluid out and effectively form skarn type deposits. However, when you do find skarn type mineralization, it's associated with a porphyry. There's a porphyry somewhere nearby, which was the main driver of fluid flow at that area or at that property. So we have known skarn type mineralization, which hosts very significant tungsten, copper, silver, and zinc mineralization at Pilot Mountain. However, as a geologist, one of the questions is, okay, well, where's the porphyry that's kind of driven the main amount of fluid flow and metal flow effectively within this part of the world? That's always a question mark, is okay, where's the associated porphyry? And a porphyry is just, it's an intrusion. It's just a big body of magma that brings in hot fluids and metals, and then those fluids can release off as the pressure releases, and then those fluids can go and find limestone units and drop the metal out. However, we're still always looking for that porphyry because that's the main driver of fluid flow. So you'll see this quick diagram here. Now, this blue illustration here is a limestone or a limestone geology, and you'll see these little red outlines. Now, these are areas where skarn type mineralization is formed. However, as you'll see here, as you follow the limestone units to the west or the left side of your screen, you'll see this red outline here. Now, this is the porphyry. This is that main magma plug that has come up here. And as you can see, this is the outline of your porphyry deposit, and then your skarn is outboard of that. So when you find skarn, the takeaway home point is you're looking for an associated porphyry, because that can be, in some cases, a very big prize as well, because porphyry deposits, if you are familiar with them, are very significant deposits of metals around the world. So that's kind of why the identification of potential porphyry deposits, or sorry, porphyry targets at Pilot Mountain is significant. And the thing about porphyries, these intrusions, is they're known to be resistive units. Typically, you'll have zonation of chargeability. These are just geophysical terms and things that we've essentially surveyed for at Pilot Mountain. And on top of that, they're associated with magnetic highs, because these intrusions, they have lots of magnetite and other magnetic minerals. So you're looking for sort of these circular magnetic highs, which are associated with resistivity, bullseye targets, and then chargeability, either rimming that or kind of overlapping with the resistivity. So now that we know sort of what porphyries look like, we'll just go back to the map at Pilot Mountain, and we're going to zoom in here on this porphyry south target. So once again, here's our skarn, known skarn type mineralization, and here's the outline. I'm just going to zoom in here. I'm going to turn on a resistivity slice. So you'll see here this circular resistivity anomaly. And now, obviously, that's an important target. However, as mentioned, the magnetics is really important. So I'm going to flip on and just quickly highlight here a magnetic survey that was done on the property historically. And there it is. So this was done in 2013, actually. And you'll see once again, and I've geo-referenced this as well, this magnetic high bullseye overlaps almost perfectly with that resistivity anomaly. So there we have that magnetic bullseye that we're looking for with the associated resistivity. So this is actually the only area on the property where magnetic surveying has ever been done. So that's the only magnetic results we have. However, the bullseye that this survey did find overlaps with our resistivity bullseye. So that's obviously has a lot of hallmarks of being a porphyry center or one of those intrusive centers that are really important. I'm just going to go back up to this section here and flip back. So once again, that's our porphyry south target. This depth slice is at about 350 to 400 meters. So you can see at depth there we have what looks to be some sort of potential porphyry center. More work needs to be done here, but this is why we've identified this as a high priority target. Flipping off here, we're just going to zoom back up quickly just to talk about the Good Hope West target. You'll see it's this sort of fingering thinner lineament target that comes in from the west here and almost intersects with Good Hope. And what we're seeing here, and this is, I apologize, this is a bit more of a complicated section here, which just comes directly from the analysis report from our geophysicists. But you'll see here this resistivity anomaly, and that's the outline that you saw on our GIS map. But you'll see here a drill hole. And the reason that this target was identified to be as high priority was we have known mineralization associated with and almost perfectly coincident with this resistivity anomaly. And just flipping back here, you'll see that this actually anomaly was traced for another, what is that, about 600 meters where it has not been drilled. However, it fingers in here to Good Hope. And as mentioned, there was a drill hole that pegged kind of the eastern extent of this resistivity anomaly, and the rest of it has not been drilled or tested to date. So that hopefully gives a bit more context as to the 5 targets that we have now identified at Pilot Mountain. A lot more work to do here. These are obviously just geophysical targets. However, we layered on additional data sets, and the story is certainly proving up here. So we're looking forward to getting further work done here and testing these targets to see what's causing these really exciting geophysical anomalies at our flagship project.